Yes, so welcome everybody to this week's problem set, which will be paper session number 3 and dealing with the topic of externalities. So yeah, I wrote it already in Moodle. I have to apologize that I am delaying or I delayed the creation of this video. The reason is simply that I got vaccinated last week over the weekend and it basically, yeah, dropped me down for 2 or 3 days. So I was feeling cold and I had fever and this kind of stuff. So that's the reason why I was not able to create the video, and hence I had to postpone it. So we will, sorry for this. So we will deal with the topic of externalities. I mean, you saw a problem set that I showed you last time, which was dealing with several exercises related to this topic. And this time we will actually dig into kind of the big, so we will deal with one paper, which is kind of the it's not the starting paper of this topic, but it's kind of a paper which has had the most impact related to this topic. So basically, it's the Coase paper that I will be talking about. You probably should have encountered the Coase theorem during your undergraduate or graduate studies. So that's kind of a yeah theorem that almost everybody who is kind of dealing with um, microeconomic theory has faced at some point. So everybody knows this theorem because it also has some quite surprising results within. Because um, you must imagine that before kind of economic theory incorporating externalities into models, we had welfare theorems due to several papers which were basically saying that markets will always lead to efficient solutions, yeah, so efficient outcomes. So if you're familiar with the first and the second welfare theorem, the first one would say that uh, every market outcome is efficient, whereas the second welfare theorem would say every efficient market outcome can be reached via lump sum transfers. And yeah, those are the basic ideas of those welfare theorems, basically saying that a government, in terms of efficiency, a government should not intervene too much in the economy because markets will always find the solutions by themselves. And starting with not only the topic of externalities, but also some other externalities, it was shown that sometimes markets do not lead to efficient outcomes. One of the reasons is externalities, because it individuals do not incorporate the externalities that they uh, expose on other participants of the market. One other thing, so the Coase paper is quite kind of popular for showing that externalities could lead to an inefficient market outcome. There is another paper which is not directly related to this, but the statement is the same. So it's the Akerlof paper on the market of lemons, where he basically showed how incomplete information in the market could also lead to an inefficient outcome. Yeah, so basically the two popular or hot topics during the, yeah, I would say, I don't know how old the Akerlof paper is. Let me just check it real quick. So the paper is The Market of Lemons. I think it should be, yeah, it's from the 70s. So this paper is from the 60s. So those were quite hot topics in the 60s and 70s in showing that, yeah, if you want to make a recommendation to policymakers, you should not blindly tell them that they shouldn't intervene in markets, because if there is incomplete information in markets or if there are externalities, the outcome of the market could be inefficient and hence regulation is needed. Yeah, so this is kind of the basic idea of the topic of externalities. And yeah, we'll talk with you about two papers which will deal with the topic of externalities. The first one is the paper, the seminal paper by Coase. It has a title, "The Problem of Social Costs," and it is a very, so I would say it's kind of an atypical paper dealing with theory, because this is a theory paper in particular. So it's a theory paper. using a lot of examples and verbal arguments to make the point. Yeah, so that's kind of, you will not find any math in the original paper. And I think the original paper was also published in an economic law journal. So I don't recall the name of it. But yeah, so it's not a, so when we are talking about this paper, or if you have a look on this paper, I uploaded both of the papers on Moodle, you will see that it's quite long and it's quite like it's almost using only verbal arguments. Sometimes there are some numbers, some tables which are used for examples to make the point, but yeah, there is no math involved, so no higher math involved in this paper. But nevertheless, the point is quite clear. And in addition, there are a lot of kind of examples for externalities described in the paper, yeah, to show you in which kind of situations you would have externalities involved in the market and where you probably would need a regulator to solve the issue of externalities because the market cannot deal by itself with the issues. So this is the Coase paper. And one issue with the Coase paper is, and it's also addressing it at some point, but not giving a solution in a real model, is that in the Coase paper, there are no transaction costs. So if the participants of the market would try to solve the issue of externalities by themselves, or if there would be a regulator, for instance, who wants to solve the issue, the assumption in the Coase paper is that there are no transaction costs involved with this. So the market works perfectly without any costs at all. And this assumption is dropped in a paper by Andalini and Felli, and has the title Costly Bargaining and Renegotiation. And this is basically a paper, so this is published in Econometrica. It has an actual model which is used to show you that once you introduce transaction costs in a market, and where individuals in the market are bargaining over outcomes, then what you will see is that the result of Coase, so that a market can deal with externalities and still get an efficient outcome, does not hold if you have um, if you have transaction costs. Okay, so basically that's the main punchline of this paper here, to show you that if you drop one of the assumptions in the original Coase paper, then you will find that the results do not hold generally. Yeah, so that's basically the plan for today, and we will start with the Coase paper. So Coase 9060, the problem of social costs. So it basically deals with, as I told you before, the question on how externalities affect markets. So what happens in a market if we introduce externalities? Basically, so what happens if actions of one participant of the market have direct negative effects or indirect negative effects on the other participant of the market? And Coe's argument in the paper, and that's quite surprising, is that simply letting the originator of the externality pay might not be desirable if you consider an efficiency point of view. Yes, so simply taking the person who is harming and letting this person pay might not be a good idea in terms of efficiency. And the reason is that you would need to have a precise look on how much damage is created on each of the party if we would allow or would not allow for the externality. Yeah, so I will be precise about this in a second. He also argues that if you have property rights which are specified and if there are no transaction costs, then if you have a bargaining mechanism, so bargaining between the participants of the market over payments and prices, then this will lead to an efficient outcome. And this is the Coase theorem, saying that even if we have externalities, the market can still get to an efficient solution as long as property rights are specified. Yeah, and that's the main difference between that's the main point in the paper, which was saying that if we have a market without externalities, okay, then and if you have a market without externalities, without incomplete information, then the market would lead to efficient outcomes. If we have externalities, the only way that we can get an efficient outcome is that property rights are specified. Yeah, so this is kind of a necessary condition, not a sufficient condition, but it's a necessary condition for efficiency to be attained. It needs to be clear who can get money from whom, depending on who's exposing this externality. So those things need to be clarified. The interesting thing about the cost theorem is that efficiency can be achieved independent of how, or of like, I think this is wrong here. Efficiency can be achieved independent of whether the originator of the externality is liable for the damage or not. So this basically means that we can attain efficiency in two ways. Either the person or the party which is exposing this negative externality is compensating the damaged party by paying it for the damage it is causing, or the party which is damaged could actually pay the damaging party in order to avoid the externality. And the interesting thing of this theorem is that it doesn't matter in terms of efficiency. And we will see later in the slides why this is the case. Yeah, so we need to have clear property rights, so it needs to be clear who has to pay whom. But for efficiency, it doesn't matter who is paying whom, but somebody needs to pay the other party. But it doesn't matter which side of the party it is. It just needs to be clear that somebody has to pay it. And that's quite interesting. But of course, for distributional matters, it definitely matters who is paying whom. Yeah, so obviously there is a redistribution happening if the originator of the externality is getting some payment from the party which is damaged due to the externality, or vice versa. Yeah, so for distributional things, it of course matters who is paying whom, but for efficiency, it doesn't matter. And that's the punchline of the cost theorem. So the second paper that I'm going to present, so Anderlini and Sally, with the title Costly Bargaining and Renegotiation, is incorporating transaction costs in a model of bargaining. And what they find is that for some particular amount of the costs, an agreement between the parties in the market is never reached in equilibrium, even though it would be efficient. Okay, so this is an argument to say that the market outcome, which is efficient, might not be reached ever in equilibrium. So what we would always observe in a market like this, so where we have externalities and costly bargaining and renegotiation, and they have full information in paper, are outcomes where we do not so we do not see any agreement at all, and hence the outcome is always inefficient. That's what could happen if you take this model literally. And in addition, for no value of costs, there exists a unique equilibrium where an agreement is reached, which means that if we find some values of costs, of transaction costs, where we find an equilibrium where an agreement is reached, which is efficient, it's never unique, which means that basically there are also other, so for those values of the cost, there are also other relevant equilibria simultaneously in the model as a prediction as the equilibrium where an efficient agreement is reached. And that's an issue because there is no reason why you should kind of see one of the equilibria over the others. Typically, what people then do is they incorporate or use some refinement equilibrium concept in order to argue that, if you use this kind of refinement, it's kind of appropriate for the question that we're trying to answer. And if it drops out one of the equilibria, then you would end up with a unique equilibrium if you're using this refinement. And that's the way that sometimes you typically get rid of multiple equilibria. But as we will see, it's very difficult to establish uniqueness of an efficient outcome. Next, what they find is that this equilibrium where agreement is reached and which is efficient, it can only be reached via inefficient punishments for out of equilibrium behavior. So basically what this is telling us is that if we are considering the on-equilibrium path, everything is fine, but once one of the participants is deviating and doing something different than the equilibrium behavior that we are imposing, the punishment of the other party to this behavior is inefficient, which is kind of very unreasonable if you're looking for efficient equilibrium. So you're simply assuming that as long as we're in equilibrium, the the participants of the market behave efficiently, and once you're out of equilibrium, they're using inefficient punishments. And there is kind of a contradiction there. So there is a kind of an issue with using this kind of reasoning to derive an equilibrium. And this is making this equilibrium where you would have an agreement a little bit problematic. And what this paper basically does, using all the arguments before, is that the Coase theorem breaks down when you introduce transaction costs. Yeah, so the statement that the market can deal with externalities by yeah, bargaining over it or using some other bargaining mechanism, um, they can overcome the externality and still yield an efficient outcome. This paper is saying that this does not hold generally if you have transaction costs. So let's start with the Coase paper before we coming to the other paper. So the basic question in the Coase paper is, how do externalities affect market outcomes? So let's consider two producers, which we denote by A and B. And let's assume that the production of A causes a negative externality on B. Think of the example that we had last time in the problem set. So think of A as the steel producer and think of B as the fishery. And the basic question is that can the circumstance be simply solved by making A to pay such that there is no negative externality anymore? So, okay, this what I wrote here is not so precise. So it should be rather, can the circumstance be simply solved or mitigated by making A to pay such that he is kind of he is made liable for the negative externality which is caused by him. So the negative externality might still be there, but A is basically forced to pay for the damage which is caused by it. And Coase is arguing that no, with a simple no, and at least no, it's a no from a efficiency point of view. Yeah, so the problem cannot be simply solved in efficiency matters by simply letting A pay to B. And the idea in the Coase paper is that if you would restrict A in order to avoid harm on B, it causes harm on A. That's a very simple kind of so it's kind of a counterintuitive thing if you think about it in the first time, but it makes sense that the externality is there. This is caused on B, but the externality is only there because A is producing. So if you then would restrict production of A in order to avoid harm on B, then A would simply produce less, and this is a harm on A, yeah, because you would restrict his production. And this is a new or novel, by that time at least a novel way of thinking about this, that even if you have negative externalities, you cannot like simply banning the negative externality by reducing the production of the party which is causing externality might not be a solution from an efficiency point of view. And the approach of Coase here is to avoid the more serious harm. You have to look how much harm is conducted by the production of A and how much harm it is imposing on B, and to look in what kind of the benefits of production of A is and what the benefit of production of B is, and to compare those things to each other, not blindly go and say that the damaging party in the market simply has to reduce production. And that's kind of a basic idea in the paper. So it depends on the market whether we should restrict the production of A or B. Basically, that's the statement. And what we will do now is we will consider market mechanisms with and without liability for damage. So first, what we'll consider is a pricing system with liability of damage for damage. So in this case, the damaging party, so firm A, has to pay for all the damage which is caused, and there are no transaction costs, which means that basically the market mechanism can give you equilibrium prices at no price. And if individuals are bargaining over the damage which is caused by the damaging party, there are no costs involved by this. So a consequence of the liability for damage is that the damaging party is internalizing the externality, because since he has to pay for the damage and the damage appears only if he produces, this is kind of an additional cost to the damaging party. Yeah, and since it's an additional cost, the benefit of additional production of the damaging party is compared to the additional cost and the additional damage on the suffering party. Yeah, so you will have uh, on top of the normal cost that you have, the production costs, you will have additional costs in form of the negative externality, which is caused on the suffering party. And the outcome here is that if you have perfect competition, and obviously if you do not have transaction costs, then an efficient outcome can be reached even in the presence of negative externalities. And the reason is simply because, as I told you before, the externality now is a direct cost for the damaging party, and hence, even if he's profit maximizing, he will consider this damage in his profit maximization, and hence you can think of this as additional costs, which then do not change anything with respect to efficiency. Yeah? So the outcome at the end will still be efficient. So we cannot make any participant of the market better without making any one participant of the market worse. So that's kind of the finding for a pricing system with liability of damage. Now, let's come to a pricing system with no liability for damage. So in this case, the damaging party is not liable for the damage which is caused. Okay, so the steel producer does not have to pay the fishery. In addition, again, there are no transaction costs. And the interesting result here, so that's kind of part of the Coase theorem, is that the same efficient outcome as in the case with liability of damage can be achieved. Okay, so uh, whatever we got from a pricing system with liability for damage, it is still there if we have no liability for damage. And what is the reason for this? So it seems quite counterintuitive at first glance. Well, the reason is that the damaged party has an incentive to pay the damaging party to reduce the externality. Yes, in so the appearance of the negative externality in both cases actually um, it's the same. So the magnitude of the negative externality does not, so the negative externality itself does not change. What kind of is different in a pricing system with no liability for damage is that now the damaging party, the damaged party actually wants the damaging party to reduce the externality in order to increase its own profits. And the idea there is that the payment that the damaged party is conducting to the damaging party can be seen as costs. So this should be those things here, not whatever was written there. So the payment of the damaged party, this can be seen as costs in the form of foregone payments. So there should be an in here. So costs in the form of foregone payments in case the damaging party decides to increase production. So imagine the following. The fishery is now, because the externality is so high, the fishery is willing to pay some monetary amount to the steel producer for the steel producer to reduce its production. So it's compensating the steel producer for reducing its production. And now, if you think about the objective function of the steel producer, it needs to incorporate this payment into its optimization problem. So if it still continues to increase production, it is not getting the payment from the damaged party. So the opportunity costs are increasing. So the opportunity costs of production are increasing due to this payment. So if you would reduce the payment, he would not only save the costs that of production by himself, but he would also get the payment from the damaged party. So basically, the two situations where you have a pricing system with liability of damage and the pricing system with no liability of damage are actually equivalent. And that's very interesting. And they're equivalent as long as there are no transaction costs and as long as the parties in the market can freely engage and trade with each other at no costs. That's quite the interesting thing here, that it doesn't matter whether we have liability for damage or whether we have liability for damage. The outcome, both outcomes will be efficient and they will be the same. And yeah, the main result of the paper is that if we have property rights which are clearly defined, so as I told you before, it doesn't matter whether it's no liability damage or whether it's liability for damage, but it needs to be clear which one of it is. Yeah, because otherwise, if you think about it, if you don't know who is liable, then how can you make somebody pay or not pay for it? Like you need to have some fixed base over which you can, or kind of fixed law base over which you can use as a market participant. Otherwise, it's unclear who has to pay whom. Yeah, so both scenarios do not differ, but still it needs to be clear which one is the scenario in charge. That's basically the Coase theorem. Yeah, not the Coast theorem, but the Coase theorem. Coase theorem. So if you have clearly defined property rights, a market solution will yield an efficient outcome. So the market outcome, the market can deal by itself with the externality. We do not need a government interfering. And yeah, as a side effect here, whether the damaging party is liable for the damage it caused or not does not matter for efficiency matters. That's also part of the Coase theorem. Obviously, it does matter in terms of redistribution. Yeah, so in terms of redistribution, obviously it matters who has to pay who in order to deal with this externality. And as I said before, in order to reach efficiency, it needs to be clear whether the damaging party is liable or not for the damage it caused. It doesn't matter for the efficiency outcome, but still, in order for the market to be able to deal with the externality, it needs to be clear whether the damaging party is liable or not. And this brings us to the other paper, so the next paper, which is then saying that this results only hold if there are no transaction costs. And this is kind of the starting point of the Andolini and Feli paper. But before I go to the other paper, let me just say some more words on the Coase paper, which I didn't include it in my presentation here. So the paper of Coase then is proceeding to give a lot of kind of real world phenomena or examples of court decisions of some economic encounters in real life, which were serving or serve as examples for the externality issues that Coase is describing here. Yeah, so that's actually the reason why the paper is so long. I think over 20, so it has 40 pages, and over 20 pages of the paper are just examples of different circumstances where externalities actually matter. And it's also giving examples of counties, countries, and places where there is a law base on how to deal with the externalities. Yeah, so it's giving a lot of examples. So if you're interested in this, feel free to have a look into the paper by yourself. For me, it was just important to give you the main punchlines of the paper, and that's why I omitted most of the examples. And he has also a discussion about um, what the introduction of transaction costs or the appearance of transaction costs in the market would have, so what effects it would have on his results. But he's doing it in a verbal way, not using a model. And since there is a very nice paper by Andolini and Feli, which I'm going to present you, I also did not include his discussion here because I think it becomes much more clear if we consider the model or the paper of Andolini and Feli. So let us then go to the next paper. As I said before, so this is by Andolini and Feli, written in 2001 with the title Costly Bargaining and Renegotiation. So in their paper, they start with the statement that if you have a world of complete information, so we are abstracting from a situation where you have incomplete information, then transaction costs imply that the cost theorem does not hold anymore, at least in the model that they're considering. So basically what it finds is that if agents costly bargain over outcomes, so basically this means there is some pie and they are bargaining over how much of, like, how high is the share of the pie for each of the participants. What they find in the paper is the following. For certain values of costs where agreement would be efficient, the unique equilibrium is given by reaching no agreement. So for basically what this is saying, that depending or for a wide range of cost parameters for the part, like the agents in the model who are bargaining over the outcome. So in those, like for many situations where an agreement would be efficient, so it would make sense to have an agreement for both of the parties. The unique equilibrium is given by reaching no agreement, which is inefficient then. Yeah, so it's a situation, so the equilibrium is a situation where we could make both individuals better. So we could make one individual better without making the other person worse. And also we could basically make both individuals better off if there would be a third party, which is yeah, kind of a mediator there. The second finding is that if an equilibrium exists where an agreement is reached, it is not unique and it can be only reached via inefficient punishment. Yes, so the second finding is that yes, for some values of the cost, we have an equilibrium where an agreement is reached, but there is also an agreement, there is also another equilibrium where we do not reach agreement. So it's difficult how to choose between the different types of equilibria. And also with respect to this equilibrium where we have agreement, it can be only reached via inefficient punishment. So via very uncredible out of equilibrium behavior. So the main model or main model extension in the paper is costly bargaining. And the paper is building upon a classical bargaining game due to Rubinstein 1982. So that's a quite famous paper. I think it was one of the first papers dealing with the topic of sequential bargaining. So very briefly in this paper, two agents are making alternating offers over potentially infinitely many rounds of renegotiations and they discount future payoffs. Um, so I can give you a very brief introduction of this model, just in case you're not familiar with it. So basically, you have, for instance, player A and player B, and they are kind of making alternating offers over um, some surplus, let's say some monetary amount of $1. Okay, and the procedure of the game is the following. So without loss of generality, A is making an offer to B. So he's telling him, let me just do something like this. So he's telling him um, how much A is getting. So we denote this by XA, and how much B is getting. This is 1 minus XA. So XA is then an element of 0 and 1. So it's a monetary amount between 0 and 1. And then B is saying yes or no. And if B is saying no, what happens is that then B is again on charge and he's then saying, I give you this amount of the surplus. And so basically it's telling that A is getting XB and B is getting 1 minus XB. And then it's again the turn of A to say yes or no. And if A says no, then the game again proceeds with A making an offer. And every time that the game breaks down, the parties will receive their outcomes, so the payments, the surplus which is shared. So if there would be an immediate agreement in the first round where where B would say yes, then A would get XA and B would get would get 1 minus XA. And one kind of assumption in the paper is that there is discounting, which means that the both parties prefer the game to end as soon as possible because there is a discount factor which is between 0 and 1. And if we have a delay in agreement, then the payments will only be delta times xb and delta times 1 minus xb. So the you can think of a pie which is shared, and the pie has a value of $1, and the value of the pie is shrinking over time because the agents in the market are uh, impatient. Yeah, so they want to have an agreement as soon as possible. Any delay is bad for them. And that's the basic Rubinstein model. Of course, it has a little bit more notation involved, but just to make the idea clear. So the extension in this paper is that in order to be able to renegotiate, both agents incur participation costs. So basically, it's saying that if one round of alternating offers is over, so if A uh, if A made an offer and B denied it, then both A and B need to pay some costs in order to reach the next round and in order to be able to make another negotiation. That's the main kind of extension because in the Rubinstein paper, reaching the next stage was costless, so there was no payment happening there. So the assumption is that only if both agents are paying, negotiations happens, else the game enters the next round, and so the next one immediately without any negotiation. So if there would be no negotiation here at this point, so no payment at this point, this would mean that we skip this negotiation round and immediately go to the next round, which then would be next round number 3, and then the discount factor would be higher, yeah, because we reached the next round and participants are impatient. So every time that one of the agents in the model does not pay, the size of the pie becomes smaller and smaller. Yeah, so that's something bad happening then. And the paper, so the model, um, kind of has also so includes a situation where nobody's ever paying. Yeah, so an equilibrium could be that no agent is ever paying this transaction costs, such that never, so there will be never negotiations happening in the paper. Okay, and the idea of those participation costs is that they can be seen as transaction costs in the form of opportunity cost of time. Because what you could think of is that every time a renegotiation is happening, both agents need to spend time on the negotiation, and this time could have been spent on other activities yielding strictly positive utility. So you can think of the costs of this renegotiation being um, the utility that you could derive from the second or the highest, or it could be the utility from the second highest um, thing that you could do, uh, like second highest yielding utility thing that you could do, absent of renegotiation. Yeah, so think of this as the transaction costs which are happening here. And yeah, this brings us to the model. So the model is quite simple. So you have two players, and players are denoted by I, and we have player A and B. The game, so the bargaining game with costs, consists of potentially infinitely many rounds of alternating offers. So it could go on forever, but it could also immediately end. So this doesn't matter. There are participation costs, CI, and those are the transaction costs. And they're saying that only both if both players are incurring this cost, then negotiations can happen. Otherwise, they cannot happen. And one assumption is that the sum of the costs is weakly lower than 1. And the reason for this is that the surplus which will be shared among the players is equal to 1. So think of $1. And the cost, the sum of the costs must obviously be lower than the total surplus because otherwise there is no reason for any of the two players to or let's say it's inefficient for the players to reach an agreement by renegotiating if the costs of renegotiation are the sum of the costs are higher than the surplus which they're sharing with. Yeah, so by this we are making sure that actually there are equilibria which are efficient. Otherwise, there wouldn't be any equilibria which are efficient. So we are avoiding a trivial problem. So one further assumption is that in odd periods, so periods 1, 3, 5, and so on, A is making an offer and B is responding. We refer to those rounds or periods as A periods, and in even periods, so 2, 4, 6, and so on, B is making an offer and A is responding. Those are the B periods. So basically, A is making an offer to B, and B is saying whether he accepts it or not. So the size of the surplus, so think of it as a pie, um, which needs to be split between the players, is normalized to 1. So you can have any other value than 1, but it's a very simple kind of way to think about this problem if you normalize it to 1, because then um, the offer that one player is giving to the other is immediately also the relative share of the pie, yeah, because it's normalized to 1. And for the rest of the paper, x will always denote a's share of the plus. Yeah, so we will have xa and xb depending on who's making the offer, but in both situations, this refers to the share of the surplus of a, not to the one of b. B will always be 1 minus xa and 1 minus xb. Yeah, just to reduce any confusion. And it's always between 0 and 1 because that's the size of the pie which is shared. And in addition, players discount with delta I, which is an element of, so they can be either super, uh, super impatient, so they do not value the pie in the future at all, or they can also be very patient, so they do not care about prolonging the renegotiations in the paper. And one kind of key feature here, which might be interesting if you haven't noticed, is that it is allowed that the players are heterogeneous with respect to the discount factor. So the player A and player B can have different degrees of patiency. And this also holds for the cost parameter. Yeah, so the cost parameter also has a player index, which means that we can also have heterogeneity with respect to the costs, which simply increase the application possibilities of the model. Because there's no reason to assume that people have the same opportunity cost of time and people have the same degree of patience. Yeah, so it's just making the model more generally applicable. So in order to understand the game easier, it makes sense to divide each period of bargaining into 3 stages. So in the first stage, sorry, both players are simultaneously deciding to pay cost CI, and this determines whether the game uh, negotiations happen or not. So if both players are paying, the game moves on to stage 2, else the game enters period n plus 1. So we do not have any negotiations in the period, in period n, but we simply go to period n plus 1, and the size of the pie is shrinking because of this. Yeah, so that's the punishment of negotiations not happening, basically. Now, if both players paid CI, then we enter stage 2, and if n is odd, A is making an offer is making an offer x to b. If n is even, p makes an offer to a. Yeah, so an offer of a is denoted by xa, and so this also implies 1 minus xa, which is the payment to b, and an offer from b is xb, which is the payment to a, and 1 minus xb is then the payment to himself. Now, if n is odd, so this is the offer which is made, then we enter stage 3. Then the party who is observing the offer sees the amount which he's receiving, and then the party either accepts or rejects the offer. So if n is odd, B is doing this. If n is even, A is doing this. If a player accepts, then the game ends and the players receive the according payoffs. So depending on whether A or B propose, they receive this payment or this payment, and you apply on this the discount factor. If a player is rejecting, the game moves on to period n+1. So what is the payoff of a player? So the payoff of a player is the share of his surplus minus the costs which he paid to negotiate, and we discount this by the discount factor. So it's not only the cost of this period, but it's the total cost of all the periods before in which we had negotiation. And if no agreement is reached, the payoffs are simply zero. Okay, so that's what they will get. They will get a payoff of zero. So there is no share of the surplus. By like small sigma A and small sigma B, so I will drop the small terms. I will always say sigma A and sigma B. We denote a pair of strategies. So a pair of strategies is kind of defining what a player is doing depending on which round he is in and whether he is um, proposing or making an offer, or whether he has to accept or deny an offer. Yeah, so that's kind of a strategy. At each point in time, it's making clear, depending on the offer that the other party made, do I accept this? And it's also making clear, what do I offer the other party in any part of the game. Yeah, so that's the strategy here. And by this big O, depending on sigma A, sigma B, we denote the outcome path that the strategies induce. Yeah, so basically, if we have a pair of strategies, it tells us, because there is no incomplete information here, it exactly tells us how the game will evolve. So how many rounds do we will pass until one of the parties is accepting the offer? Or the other extreme case, um, if a strategy is to never pay the transaction, the participation cost. So also, sorry, I forgot to mention this. Obviously, uh, one part which is also involved in the strategies is the payment of the participation costs. So this is also involved in the strategies. In the beginning of each of the periods, the strategy also defines whether the party will pay the participation costs or not. And this outcome path, so big O, depending on sigma A and sigma B, could also be the path which is simply both of the individuals never paying the participation costs. So there will be never an agreement in this game. So this is kind of the outcome path. And by big CI, which depends on the strategies, we denote the total participation costs along the outcome path. So, for instance, if we would have strategies which would yield um, an agreement after 10 rounds, then this cost function would be simply the sum of the participation costs during the last 9 rounds. Yeah, so it does not necessarily have to be the case that individuals actually negotiated during the other periods, but so this is kind of just summing up the costs of the strategies. So let's now assume that this big O sigma A sigma B induces that, yeah, the players agree on offer X in period N. Yeah, so now without loss of generality, so we not make any statement on who made the offer. So then, if this happens, the payoffs of the players are simply so the discount factor of A by the power of N, yeah, because we already negotiated, or we already had N rounds, times the surplus, the share of the surplus that A is getting, minus the costs of A, which he needed to incur in order to reach this point. Okay, so this is the payoff of A, and we have the same thing for B basically. And B is receiving 1 minus X in this round. So this is what the players are getting if they have an agreement in any period of the round, any period of the game. Now, if they never agree, The payoffs are simply given by minus Ci times sigma, so depending on sigma A, sigma B. So if the strategies of the players are in the form of never, never paying the participation cost, then there will be never an agreement, and hence, I mean, okay, in this case it will be zero, but sometimes we can also have a never agreement outcome where sometimes the individuals negotiated, but still there was a rejection of the offer. So this is what they will get basically if they never agree, but still if negotiations possibly happen. So the model, as the model of Rubinstein, will be solved by subgame perfection. So we will solve the game by backwards induction, basically. And now I will go to the theorems of the paper, so the results of the paper. So the first theorem refers or is dealing with a no agreement equilibrium. So it's basically saying that if we consider the game that I just introduced you to, and their participation costs, whatever the values of the discount factors and the participation costs are for both players, there always exists a subgame perfect Nash equilibrium of the game. So this SPE is the shortcut for subgame perfect Nash equilibrium. So there always exists a subgame perfect Nash equilibrium of the game in which neither player pays his participation costs in any period, and therefore an agreement is never reached. So what's the statement here? So the statement here is that it doesn't matter how low the participation costs are. It doesn't matter how patient the individuals are. We always have an equilibrium, a subgame perfect equilibrium, where we never reach an agreement because nobody is paying his participation costs in any period. So there will be no negotiations at all. And the interesting thing is that this equilibrium is always existent. So it doesn't depend on the discount factor or the costs. So independent of whether we will in future, like in the next slide, see that there are other equilibria, we always have this no agreement equilibrium being there. So we cannot rule it out. And that's the interesting thing is that it holds for arbitrarily low values of the participation costs. So it would hold like for the tiniest amount of participation costs that you could imagine. The second theorem is referring to an agreement equilibrium. So if we again consider the bargaining game that I introduced you before with participation costs, the game has a subgame perfect Nash equilibrium in which an agreement is reached in finite time if and only if the pair of discount factors and cost parameters for the individuals satisfy those two inequalities. So as you can see, like one immediate thing, one kind of what you demand from the parameters is, for instance, that the participants need to be sufficiently patient. Okay, so they need to be sufficiently patient because that's the only way that they value payoffs in the future, and they must be valuing payoffs in the future because if an agreement needs time to be reached, then the the surplus which is shared among them should not shrink too fast. Yeah, so that's the idea of those inequalities. And there's also, of course, some restriction with respect to the cost parameters. An interesting thing here is that if you combine theorems 1 and 2, what you can find is that there exists a region of participation costs, so exactly participation costs and discount factors, exactly the ones which do not fulfill those two inequalities, such that the unique equilibrium is one which is inefficient and where you have no agreement. Yeah, so where you only have the equilibrium of theorem 1. Because depending on the values, so if delta A and delta B are very close to 0, then the only unique equilibrium is given by no agreement, even though agreement would be efficient. Now, let's look at this picture. So this is making it a little bit clear. So here we are fixing the discount factors, and on the x-axis you find the participation costs of A, and on the y-axis you find the thing for B. And the interesting thing here is that everything which is below this dashed line, which you find here, so this dashed line which you find here, so every equilibrium or any outcome which would be here. So let me say any outcome. So any outcome which would be here is efficient because the cost of the sum of the costs of the two players in the game is strictly less than 1. And 1 is actually the size of the pie in the periods. Yeah. So and since also the costs in the future will get discounted with the discount factor, this also holds for future periods. So basically, this is telling you that you any point here is efficient, but this thing what you see here is the only situation. So the only situation which is kind of mirrored in theorem 2, where we find an agreement. So only if the cost parameters of the both players are low enough, we end up in the region of the sub-game perfect Nash equilibrium. So the region where the sub-game perfect Nash equilibrium exists, where we have an agreement. In all other cases, we would still have the possibility to reach an efficient outcome, but the only equilibrium is one where we have no agreement, which is always inefficient because they end up with a surplus of 0. Hence, the statement here is that for a wide range of parameters in this model, we actually do not have an efficient outcome. And in addition, if we have one, so which is then this region here, if we have cost parameters such that we have an equilibrium where an agreement is possible and efficient, it's not unique. So that's the issue. It's not unique because the no agreement equilibrium always exists. So theorem 3 is then um, kind of a sub-result with respect to the agreement equilibrium, which I showed you in theorem 2, because it is kind of pinning down an equilibrium type. So you can distinguish the equilibria, the agreement equilibrium in two types. So theorem 3 is pinning down an immediate agreement equilibrium. So an immediate agreement equilibrium is an equilibrium where we do not see any renegotiations, but the first offer which is made is accepted. So what this basically means is that the game either ends in the first or the second period when we have this equilibrium here. So it means that A is making an offer. So I think it doesn't even reach period 2. So maybe I might be wrong here. So I think the immediate agreement equilibrium is already saying that the game stops the first time somebody is making an offer. And since here, without loss of generality, we assume that this is A because he's making the offer in the odd periods, basically it stops in the first period. So this means that in this type of the agreement equilibria, the game stops immediately. So in the first period, because B accepts the offer that A is making, and A is making an offer such that B is actually accepting it. In addition, the outcome is efficient because we are in a world where the parameters are fulfilling inequality 1 here. So we are in this region, and this region, like outcomes in this region, are efficient outcomes. Then there is also theorem 4, which I did not explicitly put here, but theorem 4 is then actually showing that there exist equilibria where an agreement is reached, but where it is delayed by a finite number of periods. So basically, the offers would be the same. So the offers, depending on whether we are in an A subgame or a B subgame. So um, a subgame where A is making the offer or B is making the offer. We can basically get the same result, but with like it's delayed by a finite number of periods. Okay, so of course the outcomes themselves would not be the same because they will get discounted more. But from a strategical point of view, those two types of equilibria are equivalent. And this is showing you that kind of a further um, like it's a result referring to further non-uniqueness of the agreement equilibrium in that uh, even if we have an immediate agreement equilibrium, so an equilibrium where the game would stop immediately in the first period, there are also several other agreement equilibria where the game is actually delayed by a finite number of periods. And if the game is delayed by a finite number of periods, the size of the pie is shrinking more and more. And this is also a bad thing. Yeah. So it's basically to show you that so even though we have an efficient equilibrium, we also have equilibria which are inferior to this, and there is no way that we kind of select or have the participants in the market select by themselves between the equilibria because they're playing in a non-cooperative way. So what the paper then does is it's trying to introduce a new notion or a refinement of efficiency within a dynamic context. So it's introducing the notion of consistent Pareto efficiency. So basically what this demands is that a subgame perfect Nash equilibrium, denoted by sigma A and sigma B, is efficient in any possible subgame. So this means that even if we are out of equilibrium, the behavior of the individuals is efficient. So they're not making inefficient proposals. So proposals which would lead to inefficient outcomes. So this is kind of refining the notion of efficiency to make it kind of more consistent out of equilibrium. So you cannot threaten with inefficient behavior in order to reach an efficient equilibria. That's the idea of this notion of consistent Pareto efficiency. So it basically demands that if we start in any period of the game, independent of the history, the outcome of the continuation game should always be efficient. So I'm taking the strategy pair and I'm randomly dropping the players in any part of the game. What it is demanding is that then if we continue, given fixing the strategies, the outcome should be efficient. And that's kind of a refinement. And in theorem 6, the paper, they're showing that such an equilibrium does not exist. So if we introduce some notion of efficiency, which was supposed actually to drop out any of the other equilibria which were either inefficient or which were efficient but were delaying the negotiations to like potentially infinite amount of time. This theorem actually dropped down or dropped all of the equilibria where we would have an efficient outcome. So then the only efficient kind of so actually then actually there is no equilibrium existing anymore. So all of the equilibria are dropped when we use this kind of refinement. So also the inefficient ones, like not only the inefficient ones, but also the efficient ones are dropped if we use this refinement, which demands us to be also consistent with respect to efficiency out of equilibrium. And this basically concludes, it's the conclusion of the paper. So I showed you the main results of the paper, which showed you that there never exists a unique equilibrium with an efficient outcome. So I must be careful here. So a unique equilibrium using this notion of consistently Pareto efficient equilibria. So a unique, let's call it a CPEE. Have to be careful here. The efficient outcome in the presence of transaction costs, but it also holds for non-CPE. Yeah, so because it's never unique, so you have an efficient outcome equilibrium where you have agreement, but it's not unique because the subgame perfect equilibrium where no agreement is ever reached is always existent. Yeah, so basically what they're showing is that um, the statement in Coase that an efficient outcome can be reached even in the presence of externalities does not hold if we have transaction costs, which are used in this paper. In addition, what he also shows is that if we extend the notion of efficiency to a dynamic framework, no equilibrium fulfilling this criterion exists at all. Yeah, so this is referring to the CPP here. So we can drop it actually from there. There exists no equilibrium at all which fulfills this criterion of players behaving in an efficient way also out of equilibrium, which determines the equilibrium itself. And if you would apply this to an environment with externalities, so in an environment where, for instance, the prices are derived via a market mechanism, but the parties in the market need to bargain over the payment of the externality. So how much does one party have to pay has to pay to the other party? If they have to bargain over this, and you apply this model to this environment, it is saying that an efficient outcome cannot be reached. So they will never find an agreement over this payment potentially. Yeah. So um, basically, it's saying that the market itself cannot reach an efficient outcome. So it cannot efficiently deal with the externalities if we have transaction costs. And that's the basic punchline of the paper. And it finishes this week's presentation. So, as I said before, I'm very sorry that I had to postpone the video to these two papers, but still, hopefully, you got something out of it. And since it's online on YouTube, you can watch it anyways at any time that you want. So, if you still have questions with respect to papers or suggestions, please let me know. Otherwise, I see you next week. Bye bye.